Hi class, today we are looking at the rules for exponents. Your essential question is, how do I apply the rules of exponents? Your learning intention, I am learning to apply the rules of exponents. So, pause the video, you've got two warm-up questions. Can you find all the missing angles? Pause the video now, please. Well, I hope you tried. These are vertical angles, and we know that they will be congruent. So that means that 3x is equal to 2x plus 16. When I subtract 2x from both sides, I know that x is equal to 16. So how do I use that? Well, I have to put it into one of the two expressions. I think I will use 3x. So I've got 3x, but that really means 3 times 16. So that would be 30 plus 18, that would be 48. And that would be degrees. Always check your math with your calculator if you're afraid you didn't do it quite right. So 3 times 16 is 48. So I know I'm correct. So if this one's 48 degrees, then I also know that this one over here will be 48 degrees. But I'm still missing the other two. How do I find them? Well, I know that these are a linear pair. They're supplementary. Supplementary means that they add up to 180. So for the other two, I can have 180 degrees minus 48 degrees, and that will give me 132 degrees. Once again, make sure you check your math. $132 is correct. So, that wasn't very hard at all to find all of those missing angles. Okay, for the next warm-up, without any math at all, I know two of the angles. Without any math at all, I can identify two more angles. Did you see that when you were doing the problem? Well, this is 29. This is going to be 29 degrees because they're vertical. If I cover this up, I've got that line. If this one is 90 degrees, guess what the other one has to be? It is also 90 degrees. Without any math at all, I found two angles just by looking and analyzing. Okay, so if I'm looking for B, angle B, how do I find that? Well, I know that angle B plus this angle here gives me a right angle. That means they're 90 degrees. So I will take the measure of angle B is equal to 90 degrees minus 29 degrees. Okay, 90 minus 29 is almost 90 minus 30, which would be 60, but this is one less, so it will be one more, 61 degrees. Okay, now, there's two different ways to look for the last one, but they are both based off of the same idea. And you're using these vertical angles. If I cover this up, I notice that there are my linear pair. They have to add up to 180 degrees. If I cover this up, once again, you've got a linear pair that have to add up to 180 degrees. So I'll take 180 degrees minus 29 degrees. That would be 151 degrees. This one I'm not quite as sure about, so I'm going to put in my calculator. 180 minus 151, and 180 minus 151 gives me 29, so yeah, it's correct. I just did it the opposite way. 151 degrees. Okay, so if you were able to find all those angles with very little problem, then you are understanding the concept. If not, you might need more practice. Okay, so let's look at the first rule of exponent. For all a, m, and n, which are elements of our real number system, a to the m times a to the n is equal to a to the m plus n power. In other words, you add the exponents when you're multiplying and have the same base. So if I have a to the third times a to the fourth times a to the sixth, what is that equal to? Well, that will be equal to a to the 3 plus 1 plus 4 plus 6. I add them all together. That will give me a to the, there's 4, this is 10, and 4 is 14. A to the 14th power. Okay. For all a, m, n, which are elements of the real numbers, a to the m divided by a to the n equals. Okay, when we multiplied, we added. When we divide, we should, what's the opposite of adding? Subtract. Okay, so let's look at 2 to the 10th power over 2 to the 5th power. Let's make that 8th power. It'll be a little easier when we get done. So this is 2 to the 10 minus 8, which is 2 squared, which is equal to 4. If you need the visual of what we've done, okay, a pair will cross out because 2 divided by 2 is 1. Here's another pair, and so forth. Your pairs will cross out. And you're left with 2 times 2 at the top. Okay, so if you're multiplying, you add the exponents. If you're subtracting, if you're dividing, you subtract the exponents. So if we're going to raise it to a power, for all a, m, and n, which are elements of our real numbers, a to the mn is equal to what? What are we going to do? We've added, we've subtracted. What would come next? Multiplication. You multiply the exponents. So let's give ourselves an example. let's take -2. We're going to raise it to the second power. And then we're going to raise it to the fifth power. So that is -2 raised to the 10th power. Okay, so will it be a positive or a negative number? Well, if it's to an even power, it's got to be positive, because negative times negative equals a positive. If you're looking, we've got 5 sets of a positive number. So this one would be really hard to figure out in my head. So in parentheses, -2, and I'm going to raise it to the 10th power. And I end up with 1,024, and it's positive. So, if you wanted to think about what it looks like, you've got -2 squared, so that gives you 4. We've got 5 factors of 4. Okay, and for the last rule that we're going to go through, for all a and n, which are elements of the real numbers, a to the -n equals 1 over a to the n. 1 over a to the -n is equal to a to the n. In other words, you can't have a negative exponent. It will flip that expression or that number over the fraction bar. So if we're looking at 5 to the -3 power, this is equal to 1 over 5 to the 3rd power. 1 over 5 to the 3rd power. Okay, 5 times 5 is 25. I've got a quarter. If I take a 5 times 5 is 25. Times 5 again. If I've got 5 quarters, how much money do I have? I've got $1.25. So this is 1 over 125. Okay, if it is down below, it means it's going to jump up. So this is 6 squared, which gives me 36. Okay, what if they're positives and negatives on both top and bottom of my fraction bar? All I have to do is remember to flip them over. So as I'm looking at this, my smallest variable is a to the 5th. Is it positive or negative? It's positive, so it stays in the denominator. Next variable would be x to the -3. Is it positive or negative? It is negative, so that means it will flip down below the bar. Okay, y to the -9th. It's down below, that means it will flip up above. And z is positive, and we are done. So all you're going to do is if it's negative and up above, put it down in the denominator. If it's in the denominator and negative, put it up into the numerator. Okay, so why do we use exponents? Well, to find unknowns. As we get ready to solve, we still have to isolate our variable. So this is 2 times x squared equals 200. First thing I will do is to divide both sides by 2. X squared is equal to 100. What is the opposite of squaring? Well, that would be taking the square root. The square root of 100 is equal to, how many of you remember how many square roots do we have? Well, we've got the positive and we've also got the negative 10. 10 is the square root of 100. The positive is your primary. The negative is your secondary. Okay, we've got another one to solve. 2 to the negative 2 over 4 to the negative 2. Step 1. Take them to the right spot. So this is 4 squared over 2 squared. Flip them over because they're both negative, so you're looking at the reciprocal. 4 squared is 16, divided by 2 squared, which is 4, and you end up with 4. I know I'm successful when I can apply the rules of exponents to simplify expressions or solve problems. This is all about the rules of exponents.